other phone. So what do we got going tonight?
More stuff about like making them equal something else.
Verifying trig identities? Okay. Best way to do these is just to start with easy ones and work our way towards hard ones. And I've got a bunch if you don't have any. In other words, every trig textbook has a full page of these.
Here's the, okay, so this is moving on from there actually, I think.
Okay.
So it says to use the sum or difference identity to find an exact value.
Okay, this is different. Yep.
And the first one is sine 75.
Sine of 75?
Yeah, degrees.
Okay. Well, I could say that's the same as the sine of 30 plus 45. So what is the sine of A plus or minus B? What is that identity?
Is there a name for that identity?
It's the sum and difference identity for sine.
Okay, yeah.
Let's talk about it for a second, because I have an easy way of memorizing it. But the best way to memorize it is to start with the cosine one. Does your class use this same terminology, plus or minus?
Yes.
Okay. The cosine one is cosine, cosine, opposite, sine, sine. So, in other words, that's all I need to know to memorize it. It's got to be cosine, cosine. So it's got to be cosine of A, cosine of B. Opposite, meaning minus or plus, sine of A, sine of B. Okay? So once you figure out how to memorize the cosine one, it makes it a little easier to memorize the sine one. Both of them end up with two cosines and two sines in them. But in the sine, this sign is the same, not opposite. Okay, in other words, whatever I end up with over here, it's plus or minus, not minus or plus, like the cosine. And I also know that I've got a sine and a cosine, and I got a sine and a cosine over here. And the letters are different in each case. This has to be the opposite, so this must be sine of B, cosine of A. Notice there are two sines, two cosines in both. And once you get the first part of this, the second part is automatic. There's only one thing the second part can be, and that's the reverse of the first part. So back to our problem of how to find the sine of 30 plus 45. Well, let's plug it in. What's the sine of 30? Well, there's a better way to memorize it. The unit circle isn't the best way.
Okay.
It's these two triangles. Now let me erase. These two triangles will always give you these standard trig functions. The 30-60 and the 45-45. What are the dimensions on the 30-60? What's opposite the 30? I call them my unit special triangles, meaning one is always opposite the smallest angle. What's this one down here opposite the 60?
Root 3.
Hypotenuse?
2.
And the 45, 1. What's the hypotenuse?
Square root 2.
Okay. That's all you need.
Okay.
Okay? Sine of 30 is what?
1/2.
Cosine of 45 is what?
1/√2, so √2/2.
Yeah, and we can worry about rationalizing it later, but √2/2 actually works better because I've got 2's in the bottom there. Plus, not plus or minus, plus, in other words, whatever this sign is has to agree with this. In the cosine, it's always the opposite of that. And the sine of 45?
Is that also √2/2?
And the cosine of 30?
√3/2.
So we end up with √2/4 plus √6/4. And there's your answer. 1/4 times √2 plus √6.
So could we not make that √8/4, or would that not work?
That doesn't work. √2 plus √6 is not √8.
Okay.
It's √2 plus √6. Now the only thing I can do here is factor out the 4 so that my answer is 1/4 times √2 plus √6.
Okay.
But this is also satisfactory. You don't have to factor out the 1/4. So all of these sum and difference problems are going to be to figure out how to break up the angle they're asking about into two angles that we can easily figure out from these two triangles. So 75 I'm always going to break up into 30 and 45. I'm not going to break it up into 60 and 15 because I don't know what the sine of 15 degrees is. Just like I don't know what the sine of 75 is. But given this formula, I don't need the sine of 75, as all I need is the sine and cosine of 30 and 45. Okay, you got another one?
Sine of pi/12.
So we've got to figure out, we can do this two ways. One is we can convert that to an angle. In other words, degrees. And then split the degrees up. Let's do it both ways. Because you're probably not as comfortable working with radians as I am. In other words, I can split that up into pi/3 plus pi/4. Let's do it both ways, beginning that way. Okay? Now, it's not that easy to know how to split that up into pi/3 plus pi/4, but if you try adding pi/3 plus pi/4, the common denominator is 12, and you get 7 pi/12. Okay? And each of these angles is an easy one. In other words, that's 60 degrees, that's 45 degrees. So we know what sines and cosines of each of those are. Okay? So what's the sine of 60? Let's go back, bring our triangles up.
That would be root 3 over 2.
Times the cosine of 45.
Root 2 over 2.
Plus the sine of pi over 4. Remember that the sine and cosine of 45 degrees are always the same. And the cosine of 60, however, is 1/2. So in this case, we have root 6. In other words, when I multiply root 3 times root 2, it is root 6. I can multiply the insides. Over 4 plus root 2 over 4. So this becomes 1/4 times root 6 plus root 2. That's what we had last time too, isn't it? Same answer?
Yeah.
Okay.
Yeah.
Let's see if this is the same angle. The other one was 75 degrees, right?
Yeah, it was.
Well, what is 7 pi over 12? If we convert that to degrees, we're going to multiply it by 180 over pi. That's 105 degrees, right? 12 goes into 180 15 times. 15 times 7 is 105 degrees. So, the question is the sine of 75 degrees equal to the sine of 105 degrees? Because we just came up with 2 identical answers for each of these. Should that be true?
Yeah.
Yeah, because this is first quadrant. That's the second quadrant angle. That's the same thing as the 75 degree angle. And they're both positive. Sine is positive in the first quadrant, positive in the second quadrant. So the sine of 75 degrees should be the same as the sine of 105. And it was. But let's go back and do this slightly differently. Instead of working in radians, let's convert that to degrees. So I know that that's 105 degrees. And now, how am I going to split that up? Into 60 and 45, right? I mean, you don't want to split it up into 70 and 35 because we don't know those. You split it up into something that's either 30, 45, or 60.
All right.
Okay? And we'd go through exactly the same process, only working in degrees instead of radians, but plugging into the same formula and getting the same answer.
Okay.
Okay. Do you have a cosine one? Or, no, keep giving them to me because sometimes we need to subtract in order to do it. The 2 problems we've had so far, we were able to add.
Well, the next one here is a cosine one. So,
Okay.
Cosine 7 pi.
Well, again, since we just figured that that was pi over 3 plus pi over 4, and the standard cosine plus or minus b, what is it again? Just remember it's cosine, cosine, sine, sine.
Yeah. So cosine A, cosine B, minus
Minus plus
minus sine A, sine B.
Okay. So in this case, we're adding. So it's going to be cosine of pi over 3, cosine of pi over 4, minus sine of pi over 3, sine of pi over 4. What's that?
So that would be, that cosine of 30 degrees?
60. In other words, when you're converting radians, that number times that number is always 180, as long as it's pi only in the numerator. Okay? In other words, and that's a good way to memorize it, because it's really easy multiplying that times that. So pi over 6 would have to be 30 degrees. That times that has to be 180. So these 30, 45, and 60, you should kind of memorize. Okay, so if we go back to our triangles, what's the cosine of 60?
1 over 2.
Yeah. And in fact, if you want to memorize something, memorize that the sine of 30 is 1/2 and the cosine of 60 is 1/2. Because that just comes up so much. And that way, I mean, you can always refer back to these two triangles, but you do enough of these and you start, your memory memorizes it whether you want to or not. Okay? So this is root 2 over 2. And then it's minus, what's the sine of pi over 3? Sine of 60?
Root 3 over 2.
And the sine of 30, or excuse me, the sine of 45?
Root 2 over 2.
So that multiplies out to square root of 2 over 4 minus root 6 over 4, or 1/4 times root 2 minus root 6. Now, that's a negative number. Should it be?
I'm really not sure.
Pi over 3 is 60. Pi over 4 is 45. So we're taking the cosine of 105 degrees, second quadrant, cosine is negative. Okay? Let's just review this unit circle in the way I like to teach it. First of all students take calculus. Tells you what the plus or minus sign is on any trig function. So in the third quadrant, what's cosine? Plus or minus?
The third one, cosine will be minus.
Right. In other words, you know what the A, S, T, and C stand for. And it's really cosecant also, cotangent also, and secant also, because the reciprocal functions have to have the same plus or minus sign as their reciprocal. In other words, if sine is positive in the second quadrant, then so is cosecant. It's just that it doesn't make a nice little acronym or anagram, whatever they're called. Anagrams, I guess. All students take calculus. So the other important things are to remember how to take a second, third, and fourth quadrant angle and figure out what the reflex angle or the reference angle is. And the way you do that is by using these formulas. That's the first one. This is the reverse of that one. So this one is theta minus 180. and this one looks like this one only with 360 in it. So if I said the cosine of 105 degrees, well, if I put 105 degrees in there, that's the same as the cosine of 75. Only it's negative because it's second quadrant. But notice that when we were looking at the sine of 75 degrees, that's going to be exactly the same as the sine of 105 degrees, the supplementary angle. And if I said, what's the tangent of 225? What's that the equivalent of?
225 minus 180.
45.
Yeah.
What's the tangent of 45?
Just 1 or?
Yep. And the quadrant? It's positive. So the tangent of 225 would be positive 1. And it's really as straightforward as that. You don't really need to memorize the unit circle. You just really need to memorize the first quadrant results. And the first quadrant results all come from these two triangles. Every first quadrant standard angle you can get from these two triangles. And as long as you know all your first quadrant, then you can figure out second, third, fourth, 5th, 6th, 7th, 8th, 9th, 10th, all of them. So no matter what trig function I ask for and no matter what angle it is, as long as it is a multiple of 30, 45, or 60, this technique works great. Much better than memorizing the unit circle. Okay? All right. What other sum and difference? Is that all we're working on tonight, is sum and difference? Or have you gotten to half angles and double angles, that stuff also?
There's one more here.
Okay.
Tangent 15 degrees.
Okay.
We haven't done a tangent one yet.
Yeah, you're right. And we also haven't done one where we had to subtract. Just a second here. I don't do tangent very often, so I don't have that memorized right off the get-go, but since tangent is sine over cosine, you could actually say it's the sine of a plus b over the cosine of a plus or minus b. But that also reduces to, here, let me write it properly. A plus or minus b equals, well, it's actually easy to remember. It's the tangent of A plus or minus the tangent of B all over 1 minus or plus the product of the two. Okay? So, if I'm looking for the tangent of 15 degrees, I can't use addition. I'm going to have to use subtraction. Well, what two angles that are common angles subtract to 15?
45 and 30.
Okay. So I'm going to write 15 like that. Now, what's the tangent of 45?
1.
minus, what's the tangent of 30?
1/√3/3.
All divided by 1 plus opposite sign, the product of those two, which is 1 times √3/3. So it must be that. Now, when you get to this point here, it becomes an algebra, exercise in algebra, more than trig. The sine and cosine are easier to simplify. These are a little bit more difficult, but let's do it. How do I simplify that ratio? We need to find a common denominator in both cases. So let's take this numerator. What is 1 minus √3/3 going to be? Well, I can write 1 as 3/3. So now the numerator turns into 3 minus √3/3. With me?
Yeah.
And the denominator turns into 3 plus √3/3. Flip and multiply, and you just cross out the 3's, and you end up with 3 minus √3/3 plus √3. And there's the answer. Whenever you have this situation where you have a fraction over a fraction, and they have the same denominators, you can just cross them out, and whatever you got left is your answer. If they have the same numerators, you can't do that. It's the reciprocal of what's left. Okay? The safe way to do it is the way we're all used to doing this, which is to flip and multiply. But you can see that if I do that, flip and multiply, I get that. And the 3's cancel, and I'm left with that numerator over that denominator. Okay? So that one we were forced to use subtraction. Didn't have to use 45 and 30. I could have used 60 and 45. Going to get the same answer.
Yeah.
But I couldn't use addition, because there are no two common angles that add to 15 degrees. All right.
So the next one says write the equation as sine, cosine, or tangent of an angle.
Okay.
Then cosine 94 degrees, cosine 18 degrees, plus sine 94 degrees.
I get it now.
Yeah. Sine 18 degrees.
Okay, so what are we looking at? We're looking at the cosine of A, cosine of B, plus sine of A, sine of B. Well, that's the identity for the cosine sum and difference. So that should be the same as the cosine of 94 minus 18. Or the cosine of, what is that, 76? There's your answer.
Okay.
In other words, you want to be able to go both ways. You want to be able to recognize when you're looking at the identity, the sum and difference identity. And the clue here is cosine, cosine, sine, sine, and we have only two angles, 94 and 18, 94 and 18. If this was 17, we couldn't do it. But if it was 17, they're not going to give you that problem, because there's no way to answer that problem.
Yeah.
But as long as it's the two same angles, and we can get it back to this, then we can reduce it to a single trig, sine or cosine. Got another one?
Yeah. Tangent 19 plus tangent 47 over 1 minus tangent 19 tangent 47.
Okay, that's the sum or difference identity. So, is that the tangent of 19 plus 47 or the tangent of 47 minus 19?
What?
Yeah, the numerator sign is the one that's the same. It's the denominator that has the different one. So, that's the tangent of 66 degrees. Actually, this is probably the easiest one of all to memorize, if you think about it. The numerator is the same as the problem. And the denominator is just one opposite sign, the product of the two. So I don't know why I have a hard time memorizing this one. This one is actually the easiest one to memorize. But anyway.
My teacher gave us kind of like a little thing, I guess, to kind of memorize the other two, but it didn't have one.
You know, memory techniques are kind of individual, I think. Everybody has different ones, and different ones work better for some people. I have my own, and I usually try to tell the student what mine are, but you're welcome to use whatever works.
Okay.
The only difficulty with mine, I'll tell you what it is. This is easy, because you can't do this any other way as long as you remember it's cosine, cosine, opposite, sine, sine. I mean, the only letters that work are A, B, minus, plus, A, and B. So this one's relatively easy. This one might be a little harder because there is always one question. I know there's two sines and two cosines, and I know they're split, so I know it's sine, cosine, same, sine, cosine, but now I have a choice. Is it A, B, B, or is it A, B, A? And that's what you have to memorize, is that it's always A, B, which forces this to be B, A, because you know the second part is the opposite. I don't know if that's helpful or not, but that's the way I memorize.
The next one here is cosine x, cosine pi over 7 minus sine x, sine pi over 7.
So what's that going to be?
That'll be
that's the answer. Pi over 7 is a number, but x is a variable, so you can't add them together.
Yeah. The last one of those is tangent 2y plus tangent 3x over 1 minus tangent 2y tangent 3x.
I know what the rest of it is because that's all it can be. If this was anything other than this denominator, we can't reduce this to a single function. So what's this equal to?
Tangent 2y plus 3x.
That's it.
Right, the next section says prove the identity.
Okay.
Tangent of x minus pi over 2 equals negative cotangent x.
Okay. Now, you might think that we want to use the sum and difference formula, but not really. What we want to use here is the cofunction identities. Just because it's easier. We might be able to get there with the sum and difference, but we can definitely get there very quickly with the cotangent or with the cofunction identities. And by that I mean the tangent of theta is always equal to the cotangent of pi over 2 minus theta. And likewise, the cotangent of theta is always equal to the tangent of pi over 2 minus theta. All cofunctions share these properties. Cofunctions, sine and cosine are cofunctions, tangent and cotangent are cofunctions, and secant and cosecant are cofunctions. Okay, you with me?
Yeah.
Well, notice we're not looking at pi over 2 minus theta. We're looking at theta minus pi over 2. Well, that's the same as the negative of that, right? In other words, I can write tangent of x minus pi over 2 as the tangent of the negative angle pi over 2 minus x, like that. In other words, a minus b is always equal to the negative of b minus a. If you do the algebra, it's always true. So if I want to reverse the x and the pi over 2, is all I got to do is put a negative sign in front of it. Now, what we also know is that the tangent of negative x is the same as the negative tangent of x, because that's an odd function. Tangent and sine are odd. Cosine is even. So the fact that this is odd, I know that if I take the tangent of a negative angle, it's the same as negative tangent of that positive angle. Well, notice that I can take that negative sign right there and put it in front here because of that. Now, don't need that set of parentheses. And I know that the tangent of pi over 2 minus x is the same as the cotangent of x. So minus the tangent of pi over 2 minus x is the same as minus the cotangent of x. Now, just to play with it a little bit, let's see if we can use the sum and difference to show that. Well, if I use the sum and difference formula, this is tan of x minus tan of pi over 2. That presents problems. What's the tan of pi over 2? Infinity. It's infinity. It's undefined. So now I have something that's a lot harder to do anything with, because I've got infinities in there. So trying to prove that that is equal to the negative cotangent of x, not so easy. I mean, I could go through here and say that's 1 over cotan of x, so I could make that 1 over cotan of x. This is still 1 over cotan of pi over 2. That's division by 0. Excuse me. Yeah, cotan of pi over 2 is 0. So it's very difficult to prove this identity using the sum and difference. Not even sure I can. I've got too much division by 0 or infinities in there. So that's probably not the best way to do it, especially since it's relatively easy to do it the way I did it the first time. The trick, they always do this to you. I've seen this problem now about 5 times in the last week, where they don't give you pi over 2 minus x, they give you x minus pi over 2. So you have to know that that's the negative of pi over 2 minus x. And that's the secret to solving anything that has theta minus pi over 2 inside of it. Got another one?
Yeah.
I love identities. I don't know why, I just do. I love verifying identities. I guess when you do 20 hours a week of it, you get so you know those identities pretty good. Now once you know the identities really well, then these really become a piece of cake.
Okay, so we have sine of x plus pi over 6 equals square root 3 over 2 sine x plus 1/2 cosine x.
Now what are we going to use to prove this? Here, notice we're not looking at anything that resembles x minus pi over 2 or pi over 2 minus x. So we can't use the cofunction properties. But we can use the sum and difference formula. So what's the sign of a plus b equal to? Remember, there's 2 sines, 2 cosines, and they're split. So what does it have to be?
The sine of plus sine or cosine of
It's not plus, it's times cosine of b. I'm just writing the general formula. What's the rest of it?
sine of b cosine a.
Okay. Now let's plug it in for our specific problem, because our specific problem, a is x and b is pi over 6. Well, what's the cosine of 30 degrees?
Root 3 over 2.
So that's where they get the root 3 over 2 times the sine of x. And the second part, what's the sine of 30 degrees? Or sine of pi over 6. 1/2. Always memorize that, so you don't have to keep going back to that triangle. Sine of 30 is 1/2. Cosine of 60 is 1/2, because they're cofunctions. In other words, the sine of x is equal to the cosine of 90 degrees minus x. So the sine of 30 has to be equal to the cosine of 60, and they're both 1/2. So there's the 1/2. Cosine of x, that's what we were trying to prove that it was equal to.
Okay.
The tangent one was an interesting problem. Yeah. And it's always going to be like that, because tangent of pi over 2 is infinity. So whenever you have pi over 2 minus x, you don't want to use the sum and difference formula. You want to use the cofunction property. You got another one?
Yeah, one more.
Okay.
Cosine of theta plus pi over 2 equals negative sine theta.
Okay. Now, this has a pi over 2 and a theta in it, but there's no negative in the middle. So we're not going to use cofunction property. We're going to use sum and difference.
Okay.
So let's split this into its identity. What is it? Remember, it's cosine, cosine, opposite, sine, sine. So it'd be cosine what?
Cosine theta cosine over 2. That'll be minus sine theta sine pi over 2.
What's the cosine of pi of 90 degrees?
Not sure.
Okay, there's two other charts that you need to memorize. These are key. That's the cosine. This is the sine. Notice cosine of 0 is 1. Well, its next quarter point is pi over 2. Its next quarter point is pi. Its next quarter point is 3 pi over 2. And its last point is 2 pi. So what's the cosine of pi over 2?
0.
Which wipes out that whole thing. What's the sine of pi over 2?
Be 1.
Uh-huh. So there's your answer. 1 times minus sine theta, or just minus sine theta. Now there is other ways to memorize what the sine, cosine, and tangent of these quadrangles. Quadrangle is 90, 180, 270, 360, in other words, any multiple of 90. Because notice that these two triangles aren't a lot of help with that. In other words, if you look at, those two triangles, it's hard to figure out what the sine of 90 is, right?
Yeah.
So you can either memorize the unit circle, which also helps with the quadrangles, or you can memorize these two curves. Now, the advantage of memorizing these two curves is you need these two curves anyway. In other words, you want to know what the cosine curve looks like and the sine curve. Not only do you want to know what they look like, but you want to know what each quarter point is. Well, that's pi. That's 3 pi. In other words, all of the key points occur at the quarter points. So the sine of pi over 2 is 1. The sine of 0 is 0. In other words, if you can recreate these two graphs from memory, and I highly recommend being able to do that, everything you see on there, then you'll automatically know all your quadrangles for sine and cosine.
That was the last problem that I had.
Okay.
Do you have any?
Let me look. I'm in that page on my book here. It's not as easy for me to find problems like this, although here I'm seeing some that look kind of interesting. Prove the identity. Okay. We could use the sum or difference formula, but there's an easier way to do it, the way we did the tangent one. What we're looking for always on our cofunctions is this. Because we know that any trig function of this angle is the cofunction angle. So if I said, what is the tangent of that, it would be the cotangent of x. If I said, what is the sine of that, it would be the cosine of x. If I said, what is the secant of that, it would be the cosecant of x. So it's really easy if you can get the inside to look like pi over 2 minus x. Well, what do we have to do that? In other words, we can't use the cofunction property until this says pi over 2 minus x, not x minus pi over 2.
It'll be sine of negative pi over 2.
Yeah, and you got to be a little careful with your parentheses here.
Yeah.
Verify that that's the same thing. If I distribute that negative sign, it turns the x positive, and I end up with x minus pi over 2. So this is the same as that. And it's important to do that because it's really easy to leave off these parentheses and get this wrong. Okay? Now what? What can I do with that negative sign? Yeah, so it's minus sine of pi over 2 minus x. Now we can use the cofunction property. That thing is the same as cosine of x. So the whole thing has to be the same as minus cosine of x. Here's one that looks interesting. I'm not even sure I know how to do it. We're trying to prove, I mean, if you want to end on an interesting looking one. Well, there's our pi over 2 minus x. But then there's a minus y in there also. We're trying to prove that that is the sine of x plus y. I think we need to use the sum and difference to prove this. We're going to let that be A and that be B. And I'll show you what happens. So use the sum and difference to let's write this in terms of A minus B.
It'll be cosine of pi over 2 minus x. Cosine of y. That'll be plus sine of pi over 2 minus x sine of y.
Now, what is that equal to?
That equals sine.
Okay, so now we have sine of x cosine y plus, what is that equal to?
That equals cosine of x.
Sine y. Now, notice what we're I could draw a straight line. Notice what we're looking at. That is the sum and difference identity for sine of x plus y.
Yeah.
That's a good one to end on. I don't think you'll get any that are harder than that. This is a tricky one here.
Yeah.
Okay. Daniel, have a good week. I'll talk to you next Tuesday night.